Hola, all you Suhai Earth Science students. This is Mr. McLeod again. Welcome to part 3 of our series of podcasts on the structure of the Earth and plate tectonics. Today we look at earthquakes, so get your notes out, something to write with, and let's shake it up. So far we've seen the connection between volcanoes and plate tectonics. But is there a connection between earthquakes and plate tectonics? Well, if there weren't, I probably wouldn't be doing this podcast, so let's take a look. The black dots on this map of the world show us where earthquake activity is occurring. Now you can clearly see that, as with volcanoes, the earthquakes are not randomly distributed around the globe. Instead, they occur in patterns across associated plate boundaries. Write that down. I also want you to notice that this diagram of earthquake distribution closely resembles the Pacific Ring of Fire distribution of volcanism. Now, at the boundaries between plates, friction causes them to stick together, and when built-up energy causes them to break, earthquakes occur. Write that down. So what is an earthquake? As we just said, it's the sudden movement or shaking of the earth caused by plate tectonic stresses. So most earthquakes are located at plate boundaries and result in the breakage of the Earth's brittle crust. Write that down as well. Now recall from an earlier podcast that there are 3 types of plate boundaries: divergent, convergent, and transform. Movement and slipping along each of these types of boundaries can form an earthquake, and depending on the type of movement, the earthquakes can occur either in a shallow or a deep level in the crust. Get that in your notes. Now, the majority of tectonic earthquakes originate at depths of less than 100 kilometers. Also write that down. However, in subduction zones, like you see here, you see now the oceanic crust now diving below the continental crust because it's more dense. So in these subduction zones, where old oceanic crust descends beneath another tectonic plate, like is shown in this diagram, deep focus earthquakes may occur. Write that down. Now, deep focus earthquakes are earthquakes that occur in much greater depths, somewhere around 700 kilometers. Also get that in your notes. Earthquakes may also occur in areas where there are volcanoes. These earthquakes caused by 2 things. Wow, that was kind of weird. 1, by tectonic faults, and 2, by the movement of magma, otherwise known as hot melted rock or molten rock, within the volcano. Write that down. So volcanic earthquakes are caused by 2 things: tectonic faults and the movement of magma within the volcano. Volcanologists now believe that such earthquakes can be an early warning of volcanic eruptions. Yep, write that in your notes. Let's explain what we mean by plate tectonic stresses. These stresses occur at 2 locations. Let's get them in your notes. 1, at plate boundaries, which we've already explained. But they also occur, number 2, at faults. So make sure you have both of these in your notes. Well, let's define what a fault is. A fault is a crack in the Earth's crust created by two plates pulling apart, or a crack in a plate that's formed from the shifting of that plate. So get those two things that form faults down in your notes. Now, as you can see from the pictures above, tectonic plates located in a fault zone have what's called stick-slip motion. They have stick-slip motion, it's called. Write that down. Now, what this means is that any given moment in time, the plates can be undergoing one of three types of stress. So let's get these in your notes. In most cases, earthquakes are caused by transform movement that you see here in this picture, where the plates actually run past each other. So that's transform movement. Make sure you get that in your notes. So let's get these three movement possibilities that you see in this picture in your notes. Number one, the plates cannot be moving at all, which would mean nothing's happening at the surface. Yep, write these down. Number two, the plates can be building up strain, which means they are pushing against another and building up energy, but not moving yet. Almost like when you put your hands together and you try to move them like these faults here and they don't move right away, and then all of a sudden they do. Movement number three, they could slip and release all that built up energy they'd been storing up by pressing against each other. So make sure you get these three possibilities in your notes. And you can see them right here in this picture. So here's nothing happening, here's a buildup of strain, and then bam, here's the slip where a violent earthquake would occur. The sudden release of energy from this slipping of tectonic plates can cause a tremendous amount of damage, such as landslides, building damage, and what we call liquefaction. We've all seen pictures in the news of the damage done by earthquakes, and you can also see that that damage occurs in these pictures that we've shown you. I think landslides and building damage speak for themselves, but what about liquefaction? Let's look at that in a little more detail. Now, liquefaction is when a solid, in this case sand and soil, becomes saturated with water, and because of that acts like a really heavy liquid. Something like mud comes to mind as an example. Get this in your notes. Now, as a result of that, soil becomes a bit like quicksand and loses its ability to support any weight, such as roads and buildings, etc. Write that down as well. What happens now is what you see in this picture. Buildings and roads literally sink into the ground or fall over altogether. So get that in your notes as well. Now let's take a closer look at the shock waves generated by earthquakes. First, let's explain a few terms that apply to this concept. First, the focus of an earthquake is a deep place within the earth and along the fault where the slip or rupture occurs. Write that down. So a deep place within the earth along where the fault or slip or rupture occurs. The epicenter is the point on the surface of the earth directly above the focus, like you see here in this picture. So here's our epicenter located right above the focus. So make sure you get that in your notes. Now, the actual shock waves produced by an earthquake are called seismic waves, which should come as no surprise. These seismic waves are produced by the release of energy from the slip of two plates rubbing together. Get that in your notes. These waves move out in circles from the focus, kind of like ripples in a pond when a stone is dropped in it. Kind of write that example in your notes as well, because I'm probably going to ask you for some kind of an example. Now, there are three types of waves generated by this action we want to get in your notes: P waves, S waves, and L or surface waves like you see here. So make sure those get in your notes. So take a look at this picture and let's describe the action of these kinds of waves. First, P waves. P waves create the back and forth movement of rock and can travel through solid, liquid, or gas. Write that down. So you see the P waves now down here. So there are back and forth movement. S waves, like you see here, create the sideways movement of rock and can only move through solids. Get that in your notes. And then the last type of waves is the L wave or surface wave. Get that in your notes. These actually create the most damage of all three because they move in circles on the surface. Get that in your notes, and we'll talk about that here in a little bit in more detail. Now, the instrument scientists use to measure these waves, no surprise, is called a seismogram. And you see that spelling right here, a seismogram, and you see the picture of a basic seismogram right here in the bottom right. Seismograms are able to measure three things about an earthquake. So let's get these in your notes. Number one, they measure the amplitude of seismic waves, which is responsible for how much the rock moves or vibrates. Write that down. Now, you see a little bit of this seismograph right here. The height now of these waves is the amplitude. So you can see now that these are big ones and there's some smaller ones here. That's the amplitude of the wave. So if you have to jot that down in your notes and draw yourself a little picture, that'd be good too. Number two, seismographs also measure the distance from the surface to the epicenter of the earthquake. They measure the distance from the surface to the epicenter of the earthquake. And finally, a seismograph measures the actual direction of the earthquake. The actual direction of the earthquake. So get those three things down in your notes. So here's a really good look at each kind of wave and its action, just as a review. Remember that P waves shake the earth in the same direction as the wave, as you can see here in this picture. So they're the back and forth motion in the same direction as the wave. So you might want to jot that down as well. S waves shake the earth sideways to the wave direction. So again, in the picture below it, we get a chance to see the wave direction, and we also get to see that it shakes it almost perpendicular to the wave direction. So get that down as well. And then the L or surface waves actually move the rocks in a circular direction, causing most of the damage. Now get these three motion descriptions in your notes. Okay, now let's look at what's called the magnitude of an earthquake. An earthquake's magnitude measures the actual size of the seismic waves and the energy released by that earthquake. Get that in your notes. Now, you've most likely heard of what's called the Richter scale. This is the actual measurement of the energy released by an earthquake and is based on the amplitude of wave or the size of the vibration. And you see a pretty good example of that here. So this is now a Richter scale measurement. And you can see now the P and S waves that it's measuring, and there are its amplitude. Amplitude is actually defined as the distance between the midpoint and the crest or trough of the wave. So you can see the amplitude now measured by this Richter scale. Now the scale runs from 2 to about 10, with 2 being low energy and 10 being the highest possible energy. So get that in your notes. What's also important to remember about this scale is that each time we move up a number, the amplitude of the wave goes up by a factor of 10. Write that down. So for example, a 3 on the Richter scale generates waves with 10 times more energy than a 2 on the scale. Also write that down. That will absolutely be on the quiz. Lastly is the modified Mercalli scale that you see here on the left. While the Richter scale mostly measures the science behind the earthquake, i.e. the amplitude of the waves or the energy in the waves or the direction of the waves, the Mercalli scale measures the damage the earthquake does to property and people. Write that down. We don't often hear an earthquake's Mercalli scale measurement. The news often reports the Richter scale measurement for the most part. Okay, dudes and dudettes, that finishes up our discussion of earthquakes in this podcast. Submit your notes to Moodle and go grab the study guide and start answering the question. Cheers!